welcome to another 5 Numbers to Know. And today's 5 Numbers to Know is about interstellar travel. And for our intro slide here, this is an interesting graphic that was produced by NASA, and what it shows is some of the new exoplanets that have been discovered and where they lie in what's called the Goldilocks zone, or the habitable zone around these various stars. So we found a lot of exciting new planets, and some of them may be in just the right position around their star to contain life. And we're going to look at what would it take to get to some of these distant worlds, and in particular we're going to run the some of the numbers for a trip to Tau Ceti, which is about 12 light years away, and it contains not one but 2 possible planets that could be in the habitable zone. These would be super Earth. So you can see from this infographic, this is the size of our Earth here in the center, and these Tau Ceti planets would be super Earths if they're composed of the right materials and in the right position around their star. So these are maybe an exciting new world for future generations to visit. So the first numbers to know in our series about interstellar travel is 1 to 2 billion years left for Earth. So that's kind of an interesting number or number range to keep in mind. And this is a really great poster I found, and this is the web link to find it. I'll include that in the description. But this highlights the life of our sun. So from its birth to its death, this is our range, and you can see this this is a little timeline here. Now 2014 is where we are currently, and life has not existed for a very long time on planet Earth, and it's just a small fraction of the sun's overall lifespan. And the bad news is that in 1.75 billion years, and this is sort of a debatable number, but it could be in a spread of 1 billion to 2 billion years. What we know about the sun is that it will continue to run out of its hydrogen fuel and start to burn helium, at which point it will become hotter and hotter and start increasing in luminosity, making the world a much warmer place and maybe uninhabitable within 2 billion years. So we should start planning for our future and planning to explore not only other planets in our solar system, but outside of the solar system, and even find new planets on new stars. So the good news is that the sun will be so warm that Mars might even become a habitable warm place in 3.5 billion years. And towards the very end of the sun's life, when it becomes super luminous, that even the moon of Jupiter, Titan, may receive enough solar energy to be a warm and habitable place. So in 6.5 billion years, there may be the last holdouts of living things in our solar system living on Titan, making their plans to exit the solar system. So our next slide is about how fast we'd need to be going to get to this distant star. And the next number to know is 30,000 kilometers per second. That's about 10% the speed of light. So what could possibly get us up to this speed? There was a really interesting project called Project Orion. It was sponsored by the U.S. Air Force in the 1950s and 60s, and this was a nuclear-powered rocket. So this would be a huge, massive rocket that would launch mini nuclear bombs out the back of it. So it would sort of shoot these little mini nukes out the back. They'd explode behind the rocket, and the energy from the nuclear blast would push up against this pusher plate and shove the rocket forward. And so every few seconds, a nuclear bomb would be shot out the back, explode, and then push the craft forward. And this would be a massive machine. The pusher plate itself was supposed to be 50 meters in diameter. This thing was, supposed to be around 10,000 tons. Just a massive machine. It'd be more like launching a mini hotel into outer space rather than a rocket capsule. And the thing that was going to drive this, it was going to have many of these mini nukes stored on board, and it would drop them out the back. So The project was abandoned, mostly due to the risks of having all these mini nukes, but it really could open up some interesting possibilities if this was somehow made safe in the future. So this was Project Orion, and I'd encourage people to learn more about it. And at its best day, it could get us up to 30,000 kilometers per second, 10% speed of light. So going that fast, how fast would we be able to travel, and how long would it take us to reach Tau Ceti? So at that speed, 30,000 kilometers per second, 10 years it would take to travel 1 light year. So Tau Ceti is 12 light years away. That'd be 120 years travel time from our solar system to Tau Ceti. And once you reach there, it would take 12 years for the signals, the information we'd send over radio waves, to travel 12 years to Earth. So we wouldn't even know about the success of the mission until 132 years after we launched our Project Orion style rocket. So it's definitely a long-term project, but not necessarily out of the reach of possibility. Someone that may be left on the craft very young in their life, with possibly a parent or parents that maybe had children on the spacecraft, their children would live to see the new world. So it is in the possibility of for humans to live long enough to get to that distant world. And you might think, what about relativity? We're going so fast. Would we shave any time off due to time dilation? And at 10% the speed of light, you don't get a lot of savings. There's a cool calculator on Wolfram Alpha about time dilation, and over 120 years at traveling 10% the speed of light, you're only shaving about 7 months off the trip. So you're still looking about 120 years, 119.4 years of travel time. You only shave off those 7 months. And that's about the best we can do with nuclear rocket technology. So our final number, and perhaps the most important, is how much energy is this really going to take? We've got this huge, massive rocket. This is going to be a hotel type of rocket that's going to have all the supplies you need for 120 years launched into space. And we're going to be powering it with these nuclear fuels. And we're going to launch this rocket. So we're going to need 4.5 times 10 to the 21 joules of energy to get this thing going, up to 30,000 kilometers per second. And then once we begin to approach the planet, we're going to need to slow down and stop. So again, we're going to need to use the same amount of energy to slow that craft down and stop it. So if we just take the mass of our rocket times the velocity we're going to need to be traveling at, and we go through the energy is equal to 1/2 times the mass times the velocity squared, we're going to work out that we need something like 9 times 10 to the 21 joules of energy required to do a trip to Tau Ceti. And this is equivalent of roughly 40,000 Tsar bombas. So this was the largest nuclear detonation that was on October of 1961, and this is a massive release of nuclear power, and we would need the energy equivalent of about 40,000 of those types of bombs to power our nuclear rocket to a distant star. So just to review, the 5 numbers to know about interstellar travel are 1 to 2 billion years left on Earth, 12 light years distance to the nearest habitable worlds. There's a max speed that we could reach with nuclear rockets, that's 30,000 kilometers per second. 10 years to travel 1 light year at that speed. And we're going to have a large energy investment of 9 times 10 to the 21 joules of energy is going to be required to make the trip. So hope that gets you thinking about interstellar travel and some of the possibilities for future exploration. So thanks. Bye.